Hi everyone, and welcome to the first track of JFuture Online Edition 2020. Our first speaker today is Carola. She's a managing director at WPS, and she will speak about technical debt. I think that surely touches all of us in either way, right? Excellent. So I'm going to disappear from your side for some time and leave the stage entirely to you. Good luck.
Yeah, thank you very much. Hi, everybody. And thank you for having me here on JFuture. I'm going to share my screen so you will see what I want to talk to you about, and I can guide you through my talk. My name is Carola, or Carola. It depends if you're American or German or whatever. I'm from Germany, and from Hamburg in Germany. It's quite a big town. Maybe you have been there already once. And I'm gonna talk to you today about technical debt and how they hurt and what you can do to recognize them and to get rid of them in the end. And I'm a big fan of these little comics from Geek and Poke, and they are all about software development architecture. And this one is really cute to explain what happens with technical debt on the way if you are an architect. And underneath of this little comic, it says a good architect leaves a footprint, and they are looking at this diagram of an architecture, and one of them says to the other, we gave up finding proper names for the layers long ago. Since then, we name them after their architects. And if you're looking there, it's like transformation, transport, David, Mark, Judy, and John. So up there are only names. But the one thing I really like about this joke is there is a female architect in there. Judy is there. So this is what I am. I'm a female architect. I'm today even the managing director of my company WPS, and we are 120 people in my company. And this is what we did in 2019. We went to a beach to celebrate our 20 year of company, and you see a lot of female developers in there. This is something that we are very happy about. But today we are rather like this, and I guess all of you are a bit like this. We are at home, we are working from home, we are having conferences, remote, online, and it works. And this is something really great, that we can do this and that we can keep developing software. And I myself, I have studied computer science and I finished 1995, so I'm quite old already. And since then, I have been working as a programmer in the beginning. Then I started to give trainings. I started to be an architect, and I started to analyze software systems. This is since 15 years. I'm doing this with more and more colleagues from my company. And in 2015, I wrote everything down that I learned in my career and even at the university. And it was in the first place, it was a German book, but now it's also available in English. So if you're not German speaking, look into the English book. I will give you a little short part of it today and try to explain to you what I see in software systems, why there are technical debts, and what does this mean for us, that we have to live with those legacy systems, or if we start a new system, what should we do better? And what I have seen in the last 15 years is a lot of object-oriented legacy code. You can see the names of various programming languages on this slide. A lot of Java, a lot of C++, a lot of C#, of course, PHP as well, TypeScript, rather new, but anyway, object-oriented. And we have looked as well at SQL and at ABAP language, which is partly object-oriented as well. And you see some sizes there. We look at small systems up to 100,000 lines of code, but a lot of systems are much larger, up to 500,000, 1 million, 5 million, 15 million. We have seen quite huge systems, and all of them are in different shapes and have a different amount of technical depth. And I will try to show you with one diagram what actually happens in the life of a software system. In the beginning, you see here, like on the y-axis, low and high depth, technical depth, and on the x-axis, you see how much functionality I can create with my team over time. And imagine we had the most wonderful team, the most wonderful product owner, and the most wonderful customer who really allowed us to construct and build a very good first version of our system. And we put it out into the world, into production, and it has low technical depth. And then we keep on going. The users, they love our system. They want changes. They find bugs. They want enhancements. And we do this. And our main focus is to stay in this corridor of low technical depth that you can see down there, where the system has stable and low maintenance cost. And if our customers come with some ideas, some new changes, we're going to do it. But you know that maybe from your own experience, the first changes that we do, or the first version of a change, is never the best one. We think about a solution, we put it in there, and then we see, no, it should have been different. Oh, the next change is coming. Actually, we have put some technical depth into our system, and this is the yellow arrow that you see there. And if we are in a good team and have a good management, we can reduce those technical depths on our way every time at the end of an iteration, or even during the iteration. And by that, we can have this sort of wavy path through development. This is the ideal solution, and we all would love to be in a situation like that. But unfortunately, life is not like that. And we are getting into trouble with a lot of systems. What is happening here is something that we call architecture erosion. Our system gets more and more into trouble. We change, we maintain, and we put in more and more technical depth. And the color is getting into red to say this is not good. But you see as well that the arrows are getting smaller and smaller. And by this, I would want to indicate that over the time, less and less functionality can be built within a fixed unit of time, or with a budget. We get less and less done. Everything takes more and more time. You might know that, or you have heard stories about this. And if we go on this path, we end up in a corridor where the maintenance cost is really high, and it's hard to predict. You might have been in this situation. Someone wants a change, and everybody says, well, we don't know how much this will cost, or how much time this will take. Do we have to do it? Can't we just leave the system as it is and follow this never change a running system idea? I've seen a lot of teams in this situation, and it's really hard. You know, they don't sleep. They get up at night to repair the system, to restart servers, all these hassles, and it's really frustrating. So what's the way out from that situation? Actually, there are two ways out. The first one is that we really start to refactor, that we really get rid of all this technical debt. And this is something I'm going to talk to you about today. And this is a long path, and it takes time. It takes probably as much time as building up the technical debt. And often the management is hard. It's difficult to persuade the management to give us this time and give us the money. But in my experience, if you really show them what's happening in your system, I will show you some possibilities to give your management an insight. What is happening inside? Why is it so difficult? Why do you always complain that you need more time and it's also so hard? I will show you some ideas what to do. The other way out is, of course, to do it all over again. Sometimes it works to create the system again in a different language, which with a different UI framework, but it cost a lot of money as well, probably more than the refactoring, and you will have to start again. The old system will still be there. It will take time to replace it. You have seen all this, and it's really hard work too. When I look at systems, when I'm with teams, they say, oh yeah, I understand. Where are we? Are we in the green? Are we in the yellow? Are we in the red? Where are we? And what we have done is we have, over all this time with like 300 architectural reviews, we have started to create an index to explain to managers and to teams where we see them compared with other systems. And we have named this index Modularity Maturity Index, to tell people that the main focus of a good system of low technical depths, that's modularity. And the red part is you get a number between 0 and 4. Yellow is between 4 and 8. And if you are good, you get a number between 8 and 10. So this is the y-axis. And on the x-axis, there are systems. I just you just see 16 systems on the screen where we have calculated this modularity maturity index. On each unit on the x-axis is one system, and you can see some green ones, some red ones, and some yellow ones. And the size of the bubble indicates how big they are. So there is this one really big system of 15 million lines of code, and it's a really huge Java system. And the architects did a lot to create a good architecture. And we have seen this in our review. They really did a good work. And if somebody is coming new into this company to work on this system, they get a 4-day, 5-day course to understand the architecture and how are the rules in here to work on this system. It was really impressive when we saw this system. But down here, this is as well a Java system. Horrible situation. Nobody knows his way around in this source code. Well, they know their way around, but how to change something quickly, how to be sure about your changes, they really suffer. We have done a review there. This is as well a Java system, not very big, 200,000 lines of code, a small one. And this one is a C# system. So there's not just Java in here. There is C#, C++, PHP as well. And when I started to look at C# systems too, I thought, well, they are quite small all over the place. But then someone sent us to a client in Romania, and they had 10 million lines of C# code in a very, very good shape. So just to let you know, it's not about the language. It's not about the size or anything. It's about your knowledge, how a good architecture should be built, and about your possibility to reduce technical depth. But wait a minute. How did we put them up or down? Well, this is something very interesting. I have written my doctor thesis about complexity of software architecture, and to really find out what is complex in a software architecture, I went to the computer scientists and asked them, what is our brain doing with complex structures? What is easy for the human brain to understand? And the cognitive scientists said, oh, what a wonderful question. In cognitive science, we have 3 mechanisms that help human beings to get their way around in complex situations, complex structures, in towns, for example, with a complex map, or in family relations, and all this. So, and I said, oh, wonderful, what do you have? And they said, well, one thing our brain is doing is called chunking. And this means that we take things that are around us and put them into a chunk. We chunk stuff to get away from little bits and pieces. You are watching me on the screen, and you're chunking me. You're not watching my searching for all the details of my face or the earrings or the glasses, but you're chunking me, and you're thinking of me as Carola or the speaker or whatever. But imagine I would have a water pipe here coming out of my shoulder. You wouldn't be able to chunk me anymore as a speaker, because this would be strange. And this is the point. Humans can only chunk if the thing that they see is something that works together, that has a coherent appearance, that does a job together, that is close together, that has a connection. All the bits and pieces have a connection with each other. And this is such a wonderful mechanism, because it works quite well with one thing that we try to explain to everybody who is working in computer science and who's programming or is an architect or whatever. And this is the wonderful principle of, we want our systems to be modular. We want modularity. And modularity is about creating things in our architecture that form one coherent thing, that work together with one job, with one responsibility. And this is why we try to have modular systems. And the center in there is our brain needs this to find their way in the system. So if you construct your system in modules, try to find modules that have one job to do. The other thing we love are hierarchies. We love to know what is the most abstract, what is down there, where are the ups and downs, what is part of what. So humans love hierarchies to find their way around. We will look at that later. And the one perfect mechanism of our brain that is really, really helpful is that our brain is able to work with schematas. Our brain forms schematas for everything that we see in our world. So if I would tell you my both parents were teacher, your teacher schema starts to work, and you think, oh, this is why she's talking so much. Maybe you think that, or maybe you think, oh, must have been a horrible childhood, because with teachers you're always supervised a lot. My childhood was nice with my teacher parents, but anyway, it's about the schema. Schematas are very, very helpful to find our way around in the world. And this is something we have in software. We have wonderful schemata in our software, in our idea about how to create an architecture. And in architecture, or in our discipline of programming, we call this pattern. We have pattern. They are like schemas. And it's very, very important that you use patterns as they are intended to be used. I will show this with an example. The other day, I was searching with a colleague, we were programming, and we were searching a bug in a system that was constructed with design patterns. And the patterns used were like this: a model view controller in the front end, then some classes that were following a service pattern, and finally business objects and value objects. And we were coming from the front end, from the view, working our way down towards the service. And there was another class, a class called factory. You might all know the factory pattern. The factory pattern is a very old pattern from the Gang of Four, from the Goth book, which says that a factory is a class that creates objects. So like a real factory where you get things. Okay, so this is the idea of the factory pattern. And we both looked into this factory class, and this was shocking, because what did we find? We found a class that created business objects and value objects, okay, as expected, but it did other things as well. It did some calculations on business objects, and it stored the business objects into the database. My colleague and I stopped in our flow and looked at this class and asked us, what is happening here? And this is the point. The point is the factory pattern is described and explained in a way that we should use it that way. We shouldn't put other stuff in there that doesn't conform to the factory pattern, because then our schema of the factory will not work anymore. So my colleague and I started to discuss, what is this? Maybe who did this? Is this maybe not a factory? Is it another thing? But this was, our speed was gone, the flow was gone. And this is what happens if you don't use patterns consistently. So I showed you now the three cognitive mechanisms. I explained a bit on the schemata, but you have seen chunking and hierarchies as well. And we, if we want to find out if a system follows these basic rules, we do this in an architecture review, in general, with the whole team that constructed the system. And we look at the system with various tools. I've put some up there. You might know some of them. All these tools are professional tools, so they cost money. I will show you later also open source tools that you can use. And what we are trying to find out, is there modularity on all levels? Is there technical and domain layering? Are there design and architectural patterns, and are they used consistently? What is the test coverage? Are there metrics? I mean, what do the metrics tell us? So this is what we do. And this is a great thing to do. If you ever have the chance to look into your system, into the structure of your system with a tool like that, and with someone who knows its way around in the tool, you will all learn so much, because it's so amazing to discuss, and it's really architectural work to discuss with a group. Why did you do it like this? And why did someone else over there did it like this? This whole discussion helps so much in understanding the architecture and the technical depth, and get rid of them. So let's start. What do? We normally start with the question, is there a technical layering in the system, and is there a domain layering in the system? The technical layering is something that we learned already in the 90s, when people started to talk about we have to have a presentation layer, and we should not have SQL statements in the presentation layer, but they should be more downwards in the system. And we should have a domain layer where all the domain logic is in there. So they told us this. And lately, since the beginning of 2000, we have this idea of microservices. Well, maybe it's 2010, but we have this idea of microservices, of cutting systems into domain modules. And I see a lot of systems where this idea of domain modules is not really followed. And the first thing that I always try to tell people, well, at least try to have as well a hierarchy on the domain level. So you have a basic domain level and other levels that build on top. And I will show you now what we often find in systems. And the first example is a good one, a system that we looked at. It's already some years ago, and the architect knew me, and he said, well, listen, I have this Java system. It's small, just 170,000 lines of code, but we are about to do a big enhancement of a year or so with 8 people. So I really want you to come look with them at the system and repair the violations in there, in the architecture, and so that they can start with a good basis. And I did that. For a day, I was there. We all discussed around 40 refactorings they should do. And I told them, well, listen, when I come back in a year after your enhancement, I want to see a really good technical layering, but I want to see a domain layering as well. And now I will show you what we found there. Here you see the technical layering, and this is a vision from a tool, from the tool which is called Zotograph, which was on the list as well. I will show you later again the list, don't worry. And what do you see here? Well, the first thing that you might see is there are layers. There are these light gray cuttings in between of those square things, you see. So up there you see several squares. Let's talk about them as modules that form the UI layer. And then you see a very big chunk that's the business layer, and underneath there's some infrastructure and other things. So this is the technical layering, and inside of these squares, these modules are parts of the package tree of the system. And at the end, there are classes. And you all know the dependencies in a system are created by the classes, because one class calls another class to use some functionality there, some parameters, some whatsoever. And these dependencies, you can see here on the screen, the dependencies are those arcs. The green arcs are dependencies that go from up downwards. And this is why they are green, because they are conforming with the layering. So in the upmost module, there is a class that uses something from the most downward module there. This arc, this is the big arc on the left, is showing us this. When I saw this, this is the second time that I went there, I was really proud of them. And I told them, wow, you did a good job. Many things are green. There's only one red arc. This is there's a component in the business logic using something from the UI. I mean, you should never do that. And the architect, when he saw it, he said, oh, wonderful. Can I have this picture? This one component, it's the reporting component. I know it. It's horrible. We have to fix it. And if I show this picture to my boss, he will give me the money. And I said, no way. Of course you can do it. And down there, those yellow arcs, this was very easy violations, just a wrong typing. It was very easy to repair that. So this is why we changed the color to yellow. And then we took the same modules and organized them in a domain layering. And then I was really proud of them, because this is what we saw. Very good domain layering, much more layers, as you can see. So they had a quite distinct idea of what the domain was doing, and just very few arcs in the wrong direction. So a very good solution. If you end up with this after 5 years, you did a good job. This is a system that was in much more horrible state. You see a layering. Now you see the layers really closed. Before I had opened the layers so that you could see the modules. The modules are hidden here. So you just see the layers. And if you followed me before, you see a lot of green arcs, a lot of relations, dependencies that follow the layering. So quite good. And some red arcs. But unfortunately, there's one thing that I didn't tell you before. The darker a rectangle or a square is, the more is in there. And you see it on the screen. Here's in this picture, there's just one dark thing, this one layer down there. And this is the business layer. And in there was this monster. In domain-driven design, we call this a big ball of mud. These are just packages. We didn't do any organization to find out who is up or down. We just asked the tool to do a graphical organization. Those who are not needed are on top, and those only needed are at the bottom. And you see this big mess, how this system is, everything is using everything, and it's really hard to change and to get a new release out into the production. So the people really have a big problem with the system, and we saw it. Of course, if we talk about domain-driven design, we have to go further. We need separated modules, but as you have seen before in those slides, it's really difficult to arrive at some kind of hierarchy, and this is even more difficult to achieve. So what can we do? What can we do if we have a legacy system, or even we think about a new construction? Well, the first thing that you can always do is you can make the architecture visible in the source code. This helps a lot. Imagine you have 4 modules, green, purple, orange, and blue. And this is how your architecture has to be organized. This is your idea. This is how you discussed it in your team. Well, then please don't do this. Don't create a package tree or a project tree whatsoever. This is just a package tree of a system. Up there, you see it's a German system. It starts with with DE, and the name of the company is hidden. And then there are several packages, and we have colored them following the idea of the people programming the system who belong together. So this is the lilac area. This is the orange area, and it's really, really hard to find your way around if you suppose to change something in the orange area. So if you can, please do it like this. Please organize your systems as the architecture was intended. This is something that we, of course, look at in the review every time that we do a check like that. The second thing that you should absolutely do is take care of your cycles, of your class cycles or cycles on other levels. If you want to create a modular system, you need something which is basic functionality and something that's building on top. And the basic functionality should never have to use the functionality that is built on top. So this is why cycles are bad for modularity. What you see here is a system that was built in C++, but anyway, it could as well be a Java system because I've seen a lot of Java cycles. It's what you see in the middle, you see 119 classes that form a cycle. Each square there is, each rectangle is a class, and the coloring are the different components. And when I saw it, I told them, well, please, you have to reduce that. You have to work out which part is up and down and who is supposed to use whom and so on. And they said, yes, we will do that if we get money, but they didn't get money. And after a year, we ended up with a thing like this. So the whole thing got much more intense and the cycle got much bigger and bigger. And the feeling in the group was like something like this. One of them says, I cannot reproduce the bug from yesterday. And then they look, and then the other one says, maybe a time-space discontinuity has gone by and moved us into a parallel universe where this bug has never existed. And then the other one is very happy and closes the bug. Well, this is something you should really take care of. The third thing to do is look at huge things. This was a system of 9 million lines of code that we looked at. And we asked them, how many build units do you have? And they said 128. And we put the number of classes into the build units. And here you see the result. There's one build unit with 9,240 classes. This is suspicious. If you find huge things in your system, there's normally a problem. And we looked inside and we found a class cycle. I have never seen that before. This is a Java system of 5,000 classes. Clunched together in a cycle, and you can't take anything out. And I looked at the architect and I said, wow, what are you doing with this? How are you maintaining it? And he said, no, we are not touching it. We build it an interface. You see, the lilac part, there is the interface. Please don't do it. Okay. And the last thing that you can do is you can use patterns, and you can use them really well. This is inside of a domain module. This is, again, model view controller, as you should know, service as a pattern, and then patterns from domain-driven design, entity, value object, but you can name them differently. And I will show you now a system where we check the patterns. And this is important. This is something that you should do. If you have patterns in your system, they are really wonderful to get the technical depth downwards, the amount of technical depth, if you are using them in a good way and all over the place. So this is a good system. I always try to find out what patterns are there. We put them on a board here together, and then we try to recreate that view with one of those tools. So we took all the service classes and put them into a service layer, process classes, and so on. And here you see a very, very good result, because patterns tend to create hierarchies. So there are a lot of green arcs and not many red arcs. 90% of the source code was assigned to patterns. This is a very high number, and a very small number of violations between patterns. A very, very good system. If you have patterns, please do it. Please use them in a good way, discuss them in your team, and create good rules and explanations about all those patterns. Okay, so I will skip those slides because I'm getting a bit out of time. I hope I could explain to you that it's important to have modularity, hierarchical layering, and pattern consistency in your system to reduce technical debt wherever you are in your source code. Please follow the Scout rule. You can't change everything, but what do Scouts do? If they come to a place and they sleep there with their tents, their job is to leave the place in a more proper way. When they are packing up next morning, they have to clean up and better than before. And this is what you should do. If you have the job to change a class, look at it. What could be better? Should I create a test class? Is there a cycle that I should cut and destroy? Please do that. There are some free tools that you can use. You will get the slides afterwards. Maybe you know SonarQube or JQ Assistant. There are some commercial tools. I have showed you a lot of examples from Sonargraph, but there are other very wonderful tools. And I hope you don't go away here like this. I hope you take something with you. You find joy to reduce technical debt. Thank you for your attention, and I wish you a wonderful conference, and I hope I will see you again. Bye-bye.
Okay, thanks. Thank you for the great talk. Right now, yeah, we're a little bit out of time, but I think we could just we could take a few questions still.
Yeah.
And so we have some of them. I can really pick one because every question got equal numbers of like. So I'll just start with the first one.
Yeah.
Are there any special markers to decide when we need to refactor our system or completely rewrite it from the scratch? Are they only money related or some
Very good,
markers?
very good question. Well, there are actually no decisions from, I think the decision to reproduce a system, to reprogram or to refactor is nothing that we can do. It's more a commercial question. You have to discuss actually on the budget level. Do we have money and time to do it again? Because in general, from my experience, you can refactor a system. You can get downwards. I have seen 2 or 3 systems where it wasn't even possible because no tests at all, nothing. Test cases are very important from my point of view, and then you should do it. But it's really a discussion of money and budget in the end. As far as I know, what I do with my customers, we discuss. What does this mean? You're down there in the red. Do you have time and money, or is there maybe a system that you could use, or is this software system so important for your business that you can't replace it with something from a service provider, from another company? You can't buy the standard solution. You need your own because this is your special business. This creates the difference between you and your concurrents.
So it's mostly a matter of resources, right? If you have some, it's maybe better to rewrite.
Yeah.
Okay. Thanks. The second question we have: is there any way or best practices that we can avoid a tech debt since start of the development?
Yes.
And also, have you encountered such code at all?
Yes, of course. There was this one story of this system that was not small, still small, and we did architecture work. We cleaned it up. We did refactorings, and then it was much easier to change. And the most brilliant idea is to start with a good architecture, to do it right in the beginning, to have an idea. And for this, you need people with experience, and you need people who know something about modular architecture. And you have to write tests. I'm very sorry. If you don't have automated tests to a percentage of 80% or something in your business logic, you're doomed to have a lot of technical debt afterwards, because tests help a lot as well to get rid of cycles, to have small modular stuff and all this. I mean, tests are really great. So please learn about good architecture and do unit testing. I mean, this is from my point of view, the things to do.
Cool. That is a really good advice. Yeah, write test. It will help you to reduce your technical debt.
Yeah.
You can hate it, but
Yeah,
they're useful in that way.
I force all my teams to do that.
Yep. I'll check the time. 5 minutes. Yes, we have.
Another thing. Can I just add another thing?
Yep, of course.
You should always have 20% of your time in an iteration to reduce technical debt. It's not like that you start, and if you start in a well shape, you will never have technical debt. This is not the case. They will always emerge, because the first solution is never the best. So please go into a company or change company or whatever, have a management that allows it. You need 20% in every iteration to reduce technical debt. This is necessary.
Inside planning, yeah, that's also good advice. Yeah. Another question: what is your opinion about the idea of the physical visualization of the amount of technical debt? For example, the wall of technical debt. I'm not really familiar with that kind of wall. Have you heard about it?
I know, for example, that SonarCube calculates technical depths by the things that SonarCube is measuring, like long methods, huge classes. I don't know if they do cycles actually, and then they say, well, this is like 200 hours of work or something like this, you know. I don't know if this is the direction the person was heading for with the question, because I don't know the wall of technical debt neither. I would love to know. So if someone can send me a link, or please do it. You can find me in the internet. My name is, you see even my email address or my Twitter handle there. So please tell me about it. I would love to know. But I think in teams, you should know the parts of the system that have problems, and you should discuss in the group, what do we do first? How do we prioritize this? We do this in our teams too. Maybe this is the idea: a wall in the team where you have it.
Okay, all right, and definitely you could share some links with us with maybe a public chat or directly. We'll be love to see this wall of technical debt.
Yes.
And I think the last question that we have time on is what are some of the best tools to measure our system's modularity, layering correctness?
Yes.
So is there any
I moved to the slide with the commercial tools. This is because I can only discuss an architecture with the team in a workshop, and I need to have the possibility to change and try out things, to find out if the thing is in a good shape or not. These tools, they all cost money because they have this ability. You can try out things. You can do what-if analysis. What is this problem gone if we put this class over there, and all that stuff. So this is absolutely clear. They cost money, and you have to discuss it with your management. The tools that don't cost money are here, and I really, really love JQ Assistant. It's a really cool open source tool. If you have the chance, try it out. You can put rules in there. You can see graphs, how they work together, classes and all that. Most of those tools, SonarCube is a very good platform as well, but not for checking your layering. Yeah. So all these tools give you one view, and then you change the source code, and then you can ask the tool to do it again and show you again the next. What is the result? And this is better than nothing, but this is why I go into the workshops with tools that cost money, but give me the possibility to see the effects before they are programmed. Because This is often the question, can you do it in our source code? And I say, no, I can't. You have to write tests for that. But, but this is something, well, it's quicker if you have tools. This is normal. It's quicker if you pay for a tool and it gives you the possibilities.
Right. So, okay, I think we are out of time for questions. Maybe you can through Pine ask them directly. Through Color, I'm referring to our audience.
Yes,
yeah,
sure.
and we are going to transition smoothly to their next talk. And thank you, Carola. Thank you for joining us today and giving this wonderful keynote.
Yes,
thanks.
It was a pleasure. Thank you, everybody. Have a good time. And you can find me on Twitter. Bye-bye.